Okay, I'm going to start this video over again, even though there's already some blue. We're going to go over this again. 6.2, multiplying, dividing. Now, in 6.1, we talked about absolute values. We're going to assume that all variables are positive here. So in 6.2, we're not going to require you to have absolute values. If on the test, it will say make sure to have absolute values if needed, and on quizzes also, it should be clear. So first, we can combine any radicals that have the same index. You have to make sure you have the same index. If it's multiplying here, same thing as with division, but they have to have the same index to simplify. So this first one, can you simplify the product? No, I can't, because look at the index here is 3, the index here is 2, so I can't simplify. Here, my index is both of our 3, so I can multiply those two together. Negative 4 times 2 is negative 8. One thing you might realize is that's fine if we have a negative, because remember, odd index is okay to have a negative. Now, because you guys are getting so smart with your powers of 2 and 3, you would know that the cubic root of 8 is 2, and since it's negative, it's going to remain negative. 4 and 5? No, sorry, cannot combine those. 5 and 5? Well, golly gee jeeper, I can, because they have the same index. So this would be the fifth root. Now this is negative 5 times negative 2. So this would be a positive 10. And I can't simplify that any further. Now, when we're trying to actually simplify in the radical like this, you want to has a perfect nth power, but like this one was perfect. What if they don't have a perfect nth power? So let's look at this. We have already started to reduce it. You can work with perfect squares and perfect roots, but what if we don't know them off the top of my head? So let's do 6 times 4 multiplied to get 24, 3 times 2, 2 times 2. So I'm looking here. If there's no index, it's always square root. So I'm looking for pairs of 2. So here's a pair of 2s. So I'm going to circle that. There's a pair of 2 there. These do not have a pair. Once you circle, you can't use them anymore. So this simplifies to this 2, because it's circled, can come out because there was a pair there. This 3 times 2 has to remain inside the root. So 2 square root 6 would be my final answer there. Okay, now this is where you have to be careful. My index here is 3. So this would be, again, I can start with 6 times 4, 3 times 2, 2 times 2. Now I'm looking for groups of 3. Your index will tell you how many should be in a group. So index 3. So now this 3 is left over. When you are writing your final answer, the 2 comes out. This 3 stays in. And if on the test you have this answer, you will not get full credit, and people get so mad because you have to remember to write that itty bitty little 3 right there. If you don't, it's not the correct answer, because that's not the same number. Cubic root 3 is not the same thing as square root 3. So what if we have something kind of larger like this? Okay, so I'm looking for groups of 3. So I have 54, 9 times 6, 3 times 3, 3 times 2. So here's my group of 3. This is what is left over. Groups of 5. So if I were to write this out the long way, groups of 3, there's one group of 3 here, and then there's 2 left over. Another way you could think about this is like a radical is like a fraction. So if I were to do, just like how we've done before, dividing, this is the same thing as 1 and 2/3. So x 1 and 2/3, because there's 2 left over. So when I write my final answer, this 3, because there's a group of 3 right here, is outside of the root. There's one group of 3 for that x. Don't forget your itty bitty little cubic sign. This 2 was left inside because that didn't have a group of 3. And then there was 2 x's that could not be kept together. So that would be my final answer. Some people put a little thing there so you know that this is not with the x, this is with the index. Pause, and try to do B by yourself. Here's B. So again, kind of wrote it out. Look at your factor tree. I have a group of 2 here, and I have another group of 2 here. So 2 times 2 comes out. Both of those 2 comes out. This 2 did not have a group of 3. So that 2 remains inside. You should try, at the beginning, that's fine if you write out all 7 x's, but you're going to be dealing with some larger numbers. It might be harder for you. But there are 2 groups of 3. That's where this x squared comes out. Or if you write it as 7/3, okay, I can rewrite 7/3 as 2 and 1/3. 7/3 is 2 and 1/3, so 2 come out, and then there was 1 left inside. So you do not write this as a fraction because the 3 is your index. The 3 is your index. So 2 times 2 is 4. 2 x's come out, that's x squared. Your index is 3, and the 2x remains inside. So looking at multiplication for 3, I can multiply these two together just like how we did earlier. So because these indexes are the same, I can have the square root 720. Here's 1x, here's 3x, that's x to the 4th. Here's 2, here's 3. If I'm adding them, so that would be 5. Now I'm going to do my factor tree. I'm going to keep it with this. 9 times 8, 2 times 5, 3 times 3, 2 times 4, 2 times 2. I'm looking for pairs. See, there's no index, so I'm looking for pairs. So I have a pair of 3s. I have a pair of 2s. This is where you have to be careful and make sure you have nice, neat organization. This 4 has branches, so we don't do anything with the 4. If you have branches, you don't do anything with them. Here's a 2. This 5 is the only thing that was left over. Now, if I think about both of these, some people can do this part in their head, and that's fine if you can. More power to you. So this is going to come out to be an even number. So when I simplify this 3 came out, this 2 came out, this 2 came out. So 3 times 2 times 2. 3 times 2 is 6. 6 times 2 is 12. This simplifies to be a 2, so x squared. I didn't leave myself very much room here. This can be y, or 2 and 1/2. So y squared, and then we still have y 1/2. So this y squared comes out. And what we have left inside is this 5. And then this is the only y that's left in. Again, you don't write 1/2. If you write 1/2, that's not right. So this would be my answer. You should pause the video and try to do B by yourself. Pause. Here we go. I multiplied them together first, and then I just used those same two numbers. So this was a total of 6 x's, total of 7 x's. There's a pair of 3, pair of 5. So that's where this 3 and 5 come from. The 7 is left inside. That one didn't have a pair. Sad day. 6 divided by 2, because your index here is 2 if there's nothing there. 6 divided by 2 is 3, so that all of the x's come out. They simplify out. 7 divided by 2, well, that's the same thing as 3.5. So 3y is going to come out, because there's 3 groups of 2 for the y's, and there's 1 y left outside by its lonesome. When we're talking about dividing, there's actually 2 things about dividing. When we are dividing, same thing, you have to have the same index. You can divide, if they have the same index, you don't have to even rewrite it. You can simplify a fraction if you want to. So in this case, when I'm looking at this, I can look at 18 and 2 in the x's and simplify first. When we are dividing, you do not want to have a radical on bottom. So sometimes you might have to simplify the radical. But when I'm looking at this, 18 divided by 2, I can do that. So this would be the square root of 9 on top, and then I would just have a 1 on bottom. And then when I look at my x's, there's 5 x's on top, 3 on bottom, so there's more x's on top, and I'll be left with 2x. No x's are left in bottom. So now I can simplify this. Square root of 1 is 1. I don't actually need that. I don't have to keep this as a fraction. Square root of 9 is 3. Square root of x squared is x. So again, from the beginning, I said that we technically, if we were going to be wanting to be precise, we'd have to put absolute values around this. But in 6.2 and beyond, we are not going to be carrying as much. We're going to just assume that all variables are positive. So this right here would be my final answer. So if I look at this one, oops, I didn't hide my answers for the other ones. So here I have to be a little bit more careful. I'm looking at cubic. I'm not sure if 162 is divisible by 3. Well, actually, if you add up 162, if that number is divisible by 3, it is. But so 54.